Okay, hello everyone. Today we're just going to go over this FRQ of Newton's law of cooling that I found. So before you start even attempt this problem, you should probably know what Newton's law of cooling is. And it's written at the top, dt over dt, which the capitalized T represents temperature, and the lowercase t represents time. So you should know that before you do this. So so once you read the question, it says, Newton's law of cooling states that the rate of change in temperature of an object is proportional to the difference. And basically, it's just asking you to find a function of t. So what you have to do is you have to separate the variables and figure out how to write this as a function of t. So if you just want to write the differential equation, we can just simply plug numbers into the Newton's law of cooling, right? So if we do that, you would get that dt, right? The capital equals negative k times temperature minus the room of the temperature. And it says the constant temperature of the room is 68 degrees Fahrenheit, right? Does that make sense?
Yeah. What is difference between T and TS?
So TS is the constant temperature of the room. So like if I'm in a surrounding and let's say my body temperature is rising, right? When I have a fever, or in this case, we'd say cooling because it's a law of cooling, but the temperature in the house is like 75 degrees, then that's the constant temperature that you write here.
And then what is T?
T is temperature, just temperature of the in degrees, like just of the body, basically.
And when I'm looking at the paper, it says like dt over dt is like just k t minus ts. It doesn't say minus.
Yeah, I think she eliminated the negative k because if you check every other source, it's actually negative k.
Oh, so it's negative k? Okay.
Yeah. So let me move this over here. Okay. So something that was challenging was actually solving for how to find a function of t, right? And in order to do that, you'd have to separate all the variables. So let's try to get this in the form of t equals something, okay? So that's what we're trying to look for. So right now we have dt over dt is negative k times t minus 68. So what I would do is I would separate the variables. So I would say that dt over t minus 68, right, equals negative k dt. Now that I have that, I can integrate both sides, right? And then on the left side, you get ln of t minus 68 equals, what is this, negative kt plus c? Yeah.
Yes.
So in order to get rid of that ln, you would just do e to the power of. So e to the power of ln times t minus 68 equals e to the power of negative kt plus c, right?
Oh, I thought it was just a negative kt plus c.
Yeah, it is negative kt plus c.
Oh, but why is it e to the power?
Because there's a ln on the left side.
Oh, wait, sorry. Yeah, never mind. I already did that.
So if you want to, and then you can, so then it'd be t minus 68 equals e to the power of negative kt plus c. And then you add 68 to both sides, right?
Right. You could also bring the c down, right? Like,
yeah,
that's the coefficient.
68 plus c times e to the power negative k. So now that I have that, I actually have to find what c and e are, right? I mean k are.
Yes.
So let me move all this over here, and then. So I'm just gonna do it from here. So I can find what C and K are, right? So in order to find C, I can do this. If I know that T of t of 0 equals 68 plus c times e to the power of 0, right? And it's given that the initial temperature of the body is 90.3 degrees Fahrenheit. So,
I know the initial is that.
because
I know it's initial.
that's the first number.
Oh,
That's the first
right.
number I'm given because it says 1 hour later. So it's like a clue that it's the
Right.
first temperature, right? So 90.3 equals 68 plus c because e to the power of 0 is just 1. So if you subtract that, what would you get? 22.3.
So it is 0, 90.3, right? Like initial.
Yeah.
Okay. So 90.3 equals 63 plus c. Right. So c would be 90.3 minus 68.
So c would be 22.3, right?
Yes, 90.3 minus 68. Yes, 22.3.
So the only thing left that I have to make sure that this is in like the full form of equation is the k, right? So I can, so it gave me another point, t of 1. So let's try that. So let me do that in a different color. So t of 1 equals 68 plus 22.3 times e to the power of negative k, right? Because t is 1. And t of 1 is already given as 89. So 89, sorry about that, minus 68 equals 22.3 times e to the power of negative k. So 89 minus 68 is 21. So 21 equals 22.3 times e to the power of negative k. Divide 22.3 by both sides, and you'd get 0.9417, and then it keeps going on, equals e to the power, e to the power of negative k, right? 91417, and then it keeps going on and on. But let's just put out that equals e to the power of negative k. Then you can take ln of both sides, right? So ln of 0.9417 equals negative k. Divide both sides by negative 1.
0.060.
Yeah, I think that's it, right?
Yeah, I got the answer too.
Okay, so I have k equals this, c equals that. So at the top, I'm just going to finally write the final equation. So t equals 68, right? Plus e to the power of, sorry, c, you have to include the c. So 22.3 times e to the power of negative 0.06 t. That is the final equation. So the question didn't ask for that, but it's like, it's good to know that, to like know how to do that, right? Whenever you're separating variables. Okay, I'm gonna clear all this and we can work on the next part of the problem. So for this one, it says solve the differential equation to estimate the time that the murder occurred. So this one was confusing at first because I wouldn't even know like what the temperature was when he died. So what you actually have to do is you have to just estimate that by normal body temperature. So it's not, it should be 98.6, right? So what you do is you'd set 98.6.
Which, oh, okay.
Right? Because
that's estimating the time
when the murder occurred. So if your temperature is already 90.3 degrees, you're already like 6 degrees below the normal body temperature. So I think you would just assume that this is the normal body temperature. Ordered, or like when you die, your body temperature goes down, right?
Right.
So if your body temperature was initially 98.6 degrees, what is this? Okay, sorry. If your body temperature was initially 98.6 degrees, and let's say like maybe 6 hours later, it's 90 degrees, right? You're trying to figure out the time when you died, when you were murdered. right?
Right.
So we just have to assume it's 98.6 degrees. Okay? Are you okay with that, Mimi?
Yeah.
Okay. So 98, okay, so based on the equation that we found before, 98.6 equals 22.3, right? Times e to the power of, you said negative 0.06?
Yes.
So since we already did all that work in the previous question, we can easily do this, right?
Mhm.
So divide, sorry, both sides by 22.3. 4.42, let's say 2, okay, equals e to the power of negative 0.06t. So if you take ln of both sides, negative 0.6t, right? And then you divide both sides by negative 0.06. Let's see what you would get. Oh, wait, 1 second. We forgot to add the plus 68. That's completely, I missed.
Oh.
Yeah, I'm sorry. Okay, let's restart that then. So,
Right.
yeah, let's rework that. So, 98.6, right?
Yes, minus 68.
68 plus 22.3 times e to the power of negative 0.6t. So if I subtract 68 by both sides, what would I get? What is that, 30.6? Yeah.
Yeah. Like if you subtract this 30.6,
Mm-hmm. And
and
then,
then you can divide it. You're gonna divide the number by 22.3, right?
mm-hmm.
And then it's going to be 1.3722. Then you take natural log of that, and then you'll divide it by negative 0.06.
So ln of 1.3722 divided by negative 0.06, you get t equals negative 5.274 hours, right?
Yeah.
So what does this mean in the context of the problem? That means that the person was murdered 5 hours before the initial, like 9 a.m., before 5 hours before 9 a.m.
Okay,
Right?
that makes more sense because what you started with, it was 90.3, so he would have already been dead at 90.3,
Yeah,
right?
exactly.
Okay.
So if it was 5 out, like about 5 hours before 9 a.m., it'd be like 4 a.m., right?
Yeah.
So you could say approximately, or like in between 4 and 5 a.m. That's what you could say.
Uh-huh.
And then the last part of the question says call the cops and let them know. So call 911, please. Thanks so much. Okay, yeah. Let me. Okay, now we're going to continue with a volume problem, but also includes area. This is like a really hard part of definite integral, so just take it like slowly, I guess. So for the first question, first let's read the question and figure out what is what. So it says f of x is 1 plus sine 2x. So that's this function on the top right here. So this is f of x equals 1 plus sine of 2x, right? And then this g of x function is e to the power of x half, x1 half x, right? So when you're finding the area, it's just the integral of the outer function, right? Minus the inner function times dx, right?
Yes.
And before you do that, you want to figure out where these two functions intersect. And the only way you can really do that is by using the calculator. So if you plug in these two equations in the calculator, you will find that one of the intersections is actually 0, 1. So I'll write that over here. And then I'm gonna write this one over here. This intersection over here is 1.1356925, and then the y value is 1.7644625. So using this information, we can just set up a simple integral, right, to find the area of R. And I'm gonna do that in the top over here. So to find the area, I would do the integral of the outer function. In this case, the outer function would be 1 plus sine 2x, right? Right, Mimi? Is that?
Yes, yes, yes.
So 1 plus sine of 2x.
Then you would
then
subtract it.
Subtract it by
E to the power of x squared.
x half, yeah. 1/2 x, actually, yeah.
Yeah.
And then the bounds are 0, and we said that our x point was 1.1356925. So
Yes.
1.1356925. So once you plug that in your calculator, you should get 0.429.
So, but it would be like, wait, like I feel like it's more in this case since it's like sine and it has e, like it's easier to graph the intersection, right? But if you have to do it by hand, it's almost like impossible. It'll take a long time to find,
Yeah.
right? Because like
That's why, like on the FRQs for calculus, we're able to use the calculator. Okay, so for B, it deals with, okay, I'm gonna clear this, okay?
Okay.
So B deals with volume. Oh, sorry. Oh my God. Okay, so B deals with volume, right? So it says when it's revolved around the x-axis. So whenever I look at what type of method to use, I have to figure out if the strip is parallel to the axis of rotation or if it's perpendicular. So the axis of rotation in this case is the x-axis, right? And if I look at the strip here, sorry, that's a terrible strip. If I look at the strip here, the dx strip, dx is perpendicular to the x-axis. So if it's perpendicular, that means I either use the disk method or the washer method. I only use the washer method when there's like a hole, right? Or like there's a gap between the axis of rotation and the area itself. So I'm gonna use the washer method.
It's gonna be like a hole, right? If you like deflect it.
Exactly. So in this case, it's pretty easy to determine what the outer and the inner function is, right?
Right.
Because if you just like, if you do like that, you can easily see that it's the outer function is f of x, right?
Right.
So this one is fairly simple. If you have a calculator, again, you just have to set it up. So we know that the washer method is the larger area squared, the larger radius squared minus the small radius squared, right? And all of that times pi, dx or dy, depending on the equation. But since we're dealing with a perpendicular strip, we can use dx. So let's just plug in exactly what we did for A and do the same thing. So pi times the bounds would be 0 and 1.1, what was it? 356925, right?
Yes, 1.13565.
We know that the larger radius is 1 plus sine 2x squared, right? So that's the larger radius.
Yes.
And then the smaller radius is e to the power of x half squared. And then all of that with the dx. Also, another way that you could look at it is just the distance from the axis itself. Like if you take the radius from here to here, it's like fairly larger than from here to here. So you can see that that's the larger radius, right?
Right.
So once you plug this in, even if you don't like get the right answer, even plugging in the I think even having the integral formula gives you some points, right?
Yeah.
Because it's like it shows that you know how to do it, even if your calculator like might not work properly. But anyways, you should get that it's 4.267. Okay,
Right. Mhm.
so I'm gonna clear all this. And the last one deals with cross sections. So it says the region R is the base of a solid. For this solid, the cross sections perpendicular are semicircles with the diameters extending from f of x to y equals g of x. So find the volume of this solid. So in order to do a cross section, you should basically know the formula of the area of the what you're going to make a cross section of, right? So V equals ADX, right?
Yes.
So area equals 1/2 pi r squared for a semicircle, right?
Mhm.
And since it said that the diameter extends from f of x to g of x, we know that the radius is also going to be halved, right?
Mhm.
So it'd be area equals 1/2 pi times r over 2 squared. So the area of the semicircle is 1/8 pi r squared. And that's something you can also memorize because it's easier to do, just memorize it and know it. But at the same time, it's like a good way to know. So for C, all you're gonna do is the same thing, except your radius is gonna be the function as a whole squared, right? So volume equals 1/8 pi times the integral of 0 to that same 1.1356925. And in this case, you're going to have one radius, and it's going to be your larger one minus your smaller one. So 1 minus sine 2x minus e to the power of 1/2 x, all of that squared.
Mhm.
And if you just plug in this part alone, you'd get 1/8 pi times 0.197752, right?
Right.
So once you do that, divide 0.197752 by 8, multiply it by pi, and you get 0.078. And that's the answer. So this is I think this is more easier than others, but it's still a good like practice problem to run through. So thank you.